Okay, today our objectives are to determine whether a dilation is an enlargement, a reduction, or a congruence transformation. And we'll also determine the scale factor for a given translation. So a dilation, this is a transformation that may change the size of a figure. So here we start with that shape, we call it our pre-image, and our image gets larger, and we call that an enlargement. On the second one, when our shape becomes smaller, we call that a reduction. So for our scale factor, it says the amount of change for either an enlargement if it's greater than 1, or a reduction if it's less than 1. If it's equal to 1, then it is just a congruence transformation. So creating a scale factor on a coordinate plane, all you do is multiply each coordinate by the scale factor. So on this example, I say the scale factor is 5, and here's your ordered pair. So you're going to multiply 5 by each coordinate. 2 times 5 gives us 10, and 5 times -3 gives us -15. Okay, to find a scale factor on the coordinate plane, if you already have a shape drawn, what you're going to do is divide a length of the image by the length of the corresponding side of the pre-image. So here I have the scale factor is equal to the image length divided by the pre-image length. So here on this it says triangle ABC has vertices A, B, and C. Find the image after a dilation centered at the origin with a scale factor of 2. So I already drew, I've already drawn the triangle here, and what I want you to do is to do a scale factor of 2. With a scale factor of 2, you're going to multiply each of the coordinates by 2. So my new A prime, when I multiply those by 2, it's still 0, but 2 times 2 gives us 4. For B prime, we get 4, 0. And for C prime, we get 4, 6. So we'll graph those. Over 0 up 4, 4, 0, and over 4 up 6. It's slightly off my graph. And we can see that our triangle here has gotten bigger. So it is an enlargement, it's a multiplication of 2. Then it wants you to do using a scale factor of 1/2. So we should be getting smaller. And what we're going to do is we're going to look at the original value A, 0, 2, and divide those by 2 to get our A double prime. So we divide those by 2, we still have 0. 2 divided by 2 is 1. For B double prime, we divide those by 2 and we get 1, 0. And then for C double prime, we divide those by 2 and we get 1 and 1.5. Okay, so when I graph those, over 0 up 1, over 1 up 0, and then over 1 up 1.5, and that gives us our new triangle there. And we can see that it is a reduction, it has gotten smaller. Okay, on example 2 it says determine the scale factor and then determine if it's a reduction, an enlargement, or a congruence transformation. So it says initially that STUVWX is our pre-image, or our original shape, and the one on the outside is our new shape, so we can see that it's getting bigger, so it's an enlargement. After that you want to find the scale factor. Okay, the scale factor takes a length of the image. So from M to N, we were just going to go ahead and count that, which is 6, divided by a length of the pre-image. So from S to T, we can see that that is 1, 2, 3. We divide those and we get 2. So our scale factor even shows that we have gotten bigger. It's bigger than 1. On B, it says that EFG is our original shape. So we start there, and ABD becomes our new shape. So we can see that there is a reduction here. It has gotten smaller. For our scale factor, we take the image, so from A to D, that's our new image. I'm going to count those because it's easy to count. It's a vertical distance. We get 4 over our pre-image We count that distance at 6, and then we can reduce that to 2/3, and that shows it's also a reduction because it's less than 1. Okay, hopefully that will help you with your assignment 8.5 dilations worksheet. Good luck.